In the last video, you learned that this doesn't mean sexually transmitted disease. Stand by. This video is about to start.
This is the Savage Scientist Ed right here. And I'm the owner of the police car.
What's up, folks? This is the Savage Scientist Ed. And if you didn't get the joke in the beginning of this video, then that means you didn't watch my last video on user input. So you might want to go back and check that out. So it's time for us to focus on today's video. And we're going to talk about data types, variables, and naming conventions. So here's the index for this video. So jump to any of these topics that might seem interesting to you, or you could get straight into this video and follow along with me as we go through these topics one by one. So let's start talking about this stuff. In the last video, we discussed user input, and that's why all this other stuff is grayed out, because we covered it already. And today's video is on data types, variables, and naming conventions of these data types. So, what is a data type? A data type is the most primitive data structure, or the most primitive way we represent data in programming. So, a data type could be used in a situation like this. Let's say I have this cup in my hand. There are attributes about this cup that makes it so we could represent it in a programming language. This cup actually has dimensions, 3D dimensions. It has a height, depth, the X, Y, Z axis. And there's also an aspect that's called, is this cup full, or does it have items in it? So that could be represented also in programming. So let's take a look at these data types. We have three categories of our primary data types. So starting off with primary, we have our counting numbers such as int, and here's an example of an int, 31 or negative 43,298. Those are int values. So we also have float values, and if you notice, the float values has this decimal component. But float numbers can also be these large integer values. So we also have characters. Characters are alphanumeric values that cannot be compared. You can't take a character 7 and add it to 3. So characters are just symbols, such as this open parentheses or the letter A. And instead of the $, we could replace it with the number 4. And this 6 is another character. And our next primitive data type is Boolean, that just represent true, false, two states. So now it's time to talk about these three: short, double, and long. And they are actually modified types for these three, for our primary types. So you won't have to worry about Boolean when it comes to short, double, and long. There's no long Boolean type. So basically what this does is it modifies the capacity of the primitive data types. So let's take a look at int, for example. Traditionally, int is 4 bytes. So let's put that here. So if we were to go to short int, that'd be 2 bytes. So now it is 8 bytes for double. And that's where the name double comes from. So we have 16 here for long. One more quick fact. When we're looking at long, the size could actually change depending on your compiler. It could also be 8. So depending on your compiler, then that's going to determine the size of long. So we're gonna leave it there, and we're gonna talk about the size of operators soon. That's how we could determine the size of all these data types. So now it's time for us to talk about signed and unsigned. And what that basically means is that we're gonna treat all the values as either positive or a combination where half is positive and half is negative. So now let's talk about the derived data types. An array is a way of combining many of the same data types within a singular structure in order. So when we look at the word hello world, it could be looked at as an array of characters. Same data type. You can't take and put counting numbers into our array of characters. So this is just it. So you can't put Boolean values in this array of characters here. So when we get into arrays, that's where we're going to start talking more about pointers and references. So this is going to be covered in a later video, but for simplicity, we will be covering arrays pretty soon. So structs, unions, and classes. These three has a lot to do with combining some of our primitive data types into a unique data type. It's like our cup. The cup example is a real good one. So our cup would have values of int to represent the size. That'll be size. And right here would be, is it empty? So and then we'll normally write cup up here. So we're going to talk about object-oriented programming, and this is going to make a lot of sense too. So structs and unions, both of those go back to the C programming languages, and classes were added whenever it became C++. So now it's time for us to talk about data types and variables. So a variable is a particular instance of a data type whenever we use that data type. So sometimes whenever we get into functions, we're going to talk more about voids. So you can skip that one for right now, but void just means no data type at all. So null is whenever we create a data type, but we haven't assigned a value to it. So whenever we assign in values, that's when we're doing these two. So a declaration statement is whenever we declare our value, something like this, int x. So we just declared a value of int and we named it x. So to give it a value, we're going to use the assignment statement, which is really just using the assignment operator. So we will do something like this, equals 2, x equal 2. And we could also do this on a separate line or reassign it using it in the operator form. So we would say x equals 7. And yes, you know, in C++ we end our statements with the semicolon. So there it is. So that's the assignment operator and declaration statement. So now it's time for us to move on to some real coding examples so we could see this in action. This is what I called a null value because there isn't any value associated with count. But right here, we're using count without it having a value. So let's see what's going to happen. Remember, save, then push F11. So now it is showing 0 phones. So even though we didn't use it, that is kind of like the type safety that we have in the newer versions of C++. But before then, you would have got some garbage. So now it's time for us to take this same value and create it as a double. So this is our double count. And we're going to just put a value here. .98. So this is what a typical double would look like. And when we get into arithmetic operations, so whenever we're doing arithmetic, you're going to see a lot more of this type of thing. So that's our count double equals 9.98. So what's even better is being able to do something like this. Bool is high. So this is just something that's saying you're either high or you're not. You're either going left or you're going right. So we are making a decision on two things. So now we'll just change this to which way are you going? And now we're gonna change this to is high. So I guess we're looking at high or low. So let's say, so what will we set this to? We're gonna assign a value to is high. So what values could we put in is high? And if you said something like high and low, that wouldn't be correct because it's either true or false. So we could do something that's saying true is represented by high. So is high is true. So that means the other. So if you're not high, that means that you got to be low. So that's the way you look at a Boolean value. So is high. If it's true, that means it is high. So if I was to say, so let's just run it right quick. Control S and F11. So it printed a 1. So 1 means true, false means 0. So let's say false here. Let's see what's going to happen when you print whenever we do it as false. Control S. And now let's hit F11. And now we have a 0 here. So that means false. So it's 1 or 0, true or false. So let's see what else data types we could play with here. So we're going to look at a character right quick. So I just want you to know that. So character count so let's see what's going to happen whenever we print count here. You're about to really confuse somebody, but let's see what's going to happen. Compile. So duplicate names used right here. So we have a conflicting declaration. So that's what happens whenever you use the same name twice here. And the only way to get rid of something like that happen is using namespaces. So we're going to talk about namespaces in the future, but so we would say something like C count. See that C count. And now we could go and type and put our C count here. So what you think is gonna look like here? We have C count here. Let me put which way are you going equals so you could actually see what it's gonna look like here. So let's save and now run it. So this is C count, the S, and there it is. C count in our results, C count in our code, right there. So that's a basic introduction to variables. We're going to be declaring variables, and we're going to be doing this a lot in the future. So I declared some doubles down here, and we could look at those two also. Let's just move those up here. So this is how you remove the comments. You just remove those 2 backslashes. So what you think this code is gonna do? This part of the code. Exactly. It's gonna print out this. So this is one of those doubles. So what do you think the value of this is? And that's coming in our math video, but here it is. A double with a exponent of 3. So that is the same thing as saying 3. So that's just like 32 times 10 to the third power. 10 to the third power is 1,000. So that is just like saying 32 times 100. So let's see what this value is going to look like. So Control S to save and F11 to compile. Now let's bring our results over, and there it is. 32,000. Coding standards. So this is just something that you're going to see more in this course. I'm going to probably go with Camel Case. So Camel Case is whenever you start with a lowercase letter, and for each new word, we would just put a capital letter in. So if I was to say the word doghouse, the word doghouse would be written like this: D-O capital H-O-U-S-E. So kebab case just mean that doghouse would be written like this, with a hyphen in the middle, house. And snake case has been getting a lot more popular. I mean, yeah, that doesn't mean Python with the snake, but that just means that we're gonna write dog underscore house. And depending on what company you decide to work for, they're gonna have their own take on this style of coding standards. And now look at our code again. And I mean, there's not really a lot going on here. Now we just formalized the process of declaring variables. So can you tell me what's a declarative statement? What's an assignment statement in here? So if you pick this one, this is a declarative statement. And this is an assignment statement. This is a statement that does it all. It's declaring a value and assigning it a value. In our last video, I told you to modify our cell phones program that asked you how many cell phones you own, and it printed out a count of how many cell phones you own. So this is what that modification should look like. Now, you're at liberty to change this code and create your own variables, your own names, just like I did. So instead of using bank balance, you can just use balance and stuff like that. So let's do a quick walkthrough. So starting on this line, this is our main program, and this main program is this entire section, and this is our outside declaration statement. All this stuff is required to get the program running on our computer using C++. So this statement is where we declared our bank balance as an int, and right here we printed words to the screen that says enter bank balance. So on line 12, I'm asking you to enter your bank balance, and this is what it looked like in the console. On line 13, we asked the user to enter a value, and that value was stored into our bank balance. And right here, we printed the bank balance is, and we took the information from the bank balance and we dropped it into the line that says your balance is whatever you entered. And this is where the program left and returned control back to the operating system. So this is what that looks like. This is line 12. Let's enter a value. We on line 13 now. So you have 766. So this is line 13 being active. And this correlates to line 14, where it says your bank balance is 766. This 766 is this part right here that says bank balance. And we put an inline here, and that's why you see an extra space after the 766. So that's the solution to our program. We just got done talking about data types and variables and our naming conventions. Now we're about to talk about math and order of operations. That's going to be the topic of our next video. So this is the Savage Scientist Ed, the governor of the state of Swampland. So till I make my next video, peace out.